Stoichiometry. So to begin, each student will get a reaction. You're going to draw the diagram and answer the questions. So you're going to have a choice between the blue one or the green one. You're going to look at the starting materials, and based on those starting materials, you're going to predict how many particles can be created and how many different things are left over after the reaction. So go ahead and pause the video and take a couple of moments to go ahead and come up with an answer to these questions. So based on our starting materials, for our blue reaction, we are able to create 2 units of sodium chloride. There'll be no atoms of sodium left over and 2 molecules of chlorine left over. For my green reaction, we're able to create 3 units of NaCl, and we're left with 2 molecules of HCl and no molecules of NaOH left over. So what I'd like you to do is to go ahead and write down your answer to this question. How can you predict how much is made, used, and left over by a chemical reaction? So go ahead and pause the video and take a couple of moments to answer. So looking at our 2 reactions, our blue reaction and our green reaction, if you want to figure out how much is made, how much is used, how much is left over, first, for each reactant, determine how many of the product can be made. So our blue reaction, we started with 2 Na atoms and 3 Cl2 molecules. So 2 Na atoms can make 2 NaCl units because the ratio there is 1:1. We need 1 sodium for each sodium chloride. For my Cl2 molecules, 3 of those could make 6 NaCl molecules because 3 Cl2 molecules is providing 6 Cl atoms. For my green reaction, my 5 molecules of HCl could make 5 NaCl units, and my 3 NaOH molecules could make 3 NaCl units. So whichever one makes less tells you how much you can actually make. So based on my blue reaction, I can only make 2 NaCl units. After I make those 2 units of NaCl, I run out of sodium atoms. So for my green reaction, the most I can make is 3 units of NaCl because after that I run out of NaOH. So now we want to work backwards. How much of each reactant do you need to make that amount of NaCl? So if I was going to make 2 NaCl units, I will need 2 atoms of sodium and 1 molecule of Cl2. This will leave behind 2 molecules of Cl2. For my green reaction, I can make 3 NaCl units. So I'm going to need 3 HCl molecules and 3 NaOH molecules. So since I started with 5 HCl molecules, I'm going to have 2 that are left over that can't react because I've ran out of NaOH. So what we just did was stoichiometry. Stoichiometry is about predicting how much can be made, how much is used, and how much is left over during a chemical reaction. So let's practice a few problems here. So in order to do stoichiometry, we counted the number of atoms and molecules and used that to figure out how much we could make, how much was left over, and how much we used. But it's not actually convenient to count individual atoms and molecules. So the way that we do this mathematically is we work with groups of molecules. We work with moles. So a mole is a certain number of things. It's 6.02 times 10 to the 23rd items. And it's kind of like eggs. Instead of counting eggs separately, 1 egg, 2 egg, 3 egg, we count eggs by the dozen because it's more convenient. Same thing with atoms and molecules. It's more convenient to count them by moles. So in order to do stoichiometry, we need to be able to write mole ratios. So a mole ratio is the ratio between the amounts in moles of any two compounds involved in a chemical reaction. So on the screen, we have the reaction of hydrogen and oxygen to produce water. And right now, this reaction isn't balanced. I've got 1 oxygen on this side and 2 on this side. So I'm going to put a 2 in front. That will give me 2 oxygens on both sides. But now I have 4 hydrogens, so I'm going to need to put a 2 there. And remember, we don't usually write 1s because they're redundant, but there's a 1 in front of that O2. So we want to write all the possible mole ratios for this reaction. There are 6 total, including inverses. So I can say that there are 2 moles of H2 for every 1 mole of O2. I can also flip that and say that there's 1 mole of O2 for every 2 moles of H2. So go ahead and pause and write the other 4 possible mole ratios for this reaction. So based on my balanced reaction, I know that for every 2 moles of H2, there are 2 moles of H2O. And I can also flip that to put moles of H2O on top and moles of H2 on bottom. I can also write that there is 1 mole of O2 for every 2 moles of H2O, and I can flip that 2 moles of H2O for every 1 mole of O2. So these are all written as ratios, as fractions, because these are actually conversion factors. So we're going to use these in dimensional analysis to convert between moles of one thing into moles of a different thing. So let's go ahead and practice. So you're going to fill in the blanks here using the correct mole ratio in order to solve the problem. You also want to show that your units are going to cancel. So looking at A, I'm starting with 3 moles of H2, which means I need to put moles of H2 on bottom to cancel. And my answer is in moles of O2, so I need to put moles of O2 on top. Now I can just fill in the number, which based on the balanced chemical reaction is 1 to 2, and 3 divided by 2 gives me my 1.5. So you can go ahead and pause the video and work B, C, and D. So here's my answers for B, C, and D. We are using our mole ratio as a conversion factor to convert from moles of one thing into moles of a different thing. So this mole ratio is really the heart of stoichiometry. We're saying that if I start with this amount of H2, how much O2 do I need to react with that? Or if I start with this amount of O2, how much water can I make from that starting amount? So here are some practice problems. You can go ahead and pause the video and work these 3 practice problems and return here when you're ready to check your work. So for 3A, we're starting with 10 moles of NH3, and I want to know how many moles of N2 would I need to make those 10 moles of NH3. So I'm going to start by writing my 10 moles of NH3 over 1, and on bottom, I'm going to put moles of NH3, and on top, I'm going to put moles of N2. So anytime you see moles and moles, that means you're going to need to use a mole ratio. And your mole ratio always comes from your balanced equation. So this equation right now is not balanced. If I put a 2 here, that will take care of nitrogen, but then that gives me 6 hydrogens, so I'm going to need a 3 here and a 1 here. So for every 1 mole of N2, there are 2 moles of NH3. So in order to form 10 moles of NH3, we're going to need to start with 5 moles of N2. If 3 moles of H2 were used, how many moles of NH3 could be made? So I'm going to put mole of H2 on bottom to cancel, and moles of NH3 on top, because that's what we're solving for. and this ratio is 2 to 3. So when I solve this, I get 2 moles of NH3. So if I started with that 3 moles of H2, I'm going to get 2 moles of NH3. Now we could have actually just predicted this by looking at the reaction, because in the balanced equation, you're given 3 and 2. Last one, if 0.6 moles of NH3 are produced, how many moles of H2 are required? So I'm going to put mole of NH3 on bottom and mole of H2 on top. And from my balanced equation, that ratio is 3 to 2. So when I solve here doing my math, I get 0.900 moles of H2. So all of these questions are really about, if you start with a certain amount of ingredients, how much product can you make? How much of the excess reactants are going to be left over? So really, stoichiometry is just about how much can be used, how much can be formed, and how much is left over during a chemical reaction. Now what we just did was we went from moles of a given to moles of something else, and we did that using a mole ratio. But we don't have scales that measure in moles. In fact, we don't count atoms by the mole, we count atoms by grams, or by volume of gas, or by number of particles, or molarity. So sometimes you will be given moles and asked for moles, but you could be asked for many other different units, or you could be given many different other units. So whatever units you are given, you're going to change those into moles. You could be given liters of gas, grams of a substance. You could be given particles or molecules. Or you could be given molarity and liters. But whatever you are given, you need to change it into moles. Then, once you've converted into moles, you're going to use a mole ratio to take the moles that you were given and convert it into moles of what we want, what the problem asks for. And then convert that into whatever units it asks for in the problem. So let's practice. So here we have a reaction, and it says how many grams of lithium are needed to produce 10 grams of lithium chloride. So right at the top, we have our equation. We're going to go ahead and need to balance that in order to get our mole ratios. So I'm going to put a 3 here to balance out the chloride, which means I need a 3 here to balance out the lithium, and I have a 1 and a 1. So in this problem, we are given 10 grams of lithium chloride. We are asked for grams of lithium. So looking at our roadmap here, we're given grams and we are asked for grams. So I need to take grams and use my molar mass to convert it to moles, then my mole ratio to convert it into moles of what I'm asking for, and then I'm going to use molar mass again to get my grams for my final answer. So my plan here is to take grams of LiCl, convert it into moles of LiCl, then convert that into moles of Li, and then convert that into grams of Li. So let's go ahead and solve this one. So I'm going to start with my 10 grams of LiCl over 1. Now in my first step here, I need to change grams of LiCl into moles of LiCl. Next, I'm going to change my moles of LiCl into moles of my wanted quantity, which is lithium. And then finally, I can change moles of lithium into grams of lithium. So now that we have this set up, we can go ahead and fill in some numbers here. So my first one here is grams and moles, which means molar mass. So I need to find the molar mass of lithium. So I'm going to take the mass of lithium plus the mass of chloride, add those together, and that'll give me my molar mass for lithium chloride. So I get 42.394 for my molar mass. So that is the mass of 1 mole of lithium chloride. Now we got mole and mole, so this means we need a mole ratio, which comes from our balanced equation. In my balanced equation, my ratio is 3:3. And my last one, once again, has grams and moles, so I'm going to need to find molar mass, but this time I just need the molar mass of lithium. So 1 mole of lithium weighs 6.941 grams. So plugging this all into our calculator and solving, my answer is 1.64 grams of lithium. So we just figured out if I wanted to make 10 grams of lithium chloride, how many grams of lithium would I need to start the reaction with to generate that 10 grams? And we get 1.64. Now, you might be confused. If we have 10 grams of lithium chloride, shouldn't we at least have 10 grams of lithium? Lithium chloride and lithium have very different molar masses. So that 1.64 grams of lithium is going to go pretty far towards making lithium chloride. The next question is asking you how many grams of aluminum are consumed if 30.5 grams of lithium chloride are produced. So in other words, I'm saying how many grams of aluminum are we going to also make here when we produce this 30.5 grams of lithium chloride. So go ahead and pause the video and take a couple of minutes to work through this problem. So I'm going to go ahead and balance this. We need a balanced equation. And we're starting with 30.5 grams of lithium chloride. And we want to know how many grams of aluminum will also be produced here. So I'm going to take my grams of lithium chloride and convert that into moles of lithium chloride, then into moles of aluminum, and then into grams of aluminum. So starting with my 30.5 grams of lithium chloride over 1, I need to put grams of lithium chloride on bottom and moles on top. Next step is going to be my mole ratio. So moles lithium chloride on bottom and moles aluminum on top. And then I want my final answer to be in grams of aluminum. So moles of aluminum on bottom to cancel, grams of aluminum on top. That's what we're solving for. So first one I have here is grams and moles, which means molar mass. So the molar mass of lithium chloride, we add the lithium 6.941 to chlorine's 35.453. And I get that 1 mole of lithium chloride weighs 42.394 grams. Next, we have our mole ratio, which is 1:3. And then lastly, we need the molar mass of aluminum, which is given to us here. So I get that 1 mole of aluminum has a mass of 26.982 grams. So when I solve this, I get 7.19 grams of aluminum. So if I were to produce 30.5 grams of lithium chloride, that means that I would also be producing 17.19 grams of aluminum. So what we just calculated in those practice problems was what we call a theoretical yield. So a theoretical yield is the calculated amount of product that can be produced from a given amount of reactants if everything in the lab goes perfectly. Lab work is never perfect, so this is going to result in an experimental yield that is less than our theoretical yield. So we can express this amount that we actually get as a percent yield. The highest possible percent yield is 100%, but in practice, this will never occur. So to find the percent yield, you take the experimental yield. This is what you get when you actually do the reaction, and you divide it by the theoretical yield. This is what your math, what you would calculate to be your yield. Divide those and multiply by 100%. So let's go ahead and try number 6. So what is the theoretical yield in grams of FeCl3 if 3 liters of Cl2 gas are used? So we are using a new term here, theoretical yield, but what you're doing is the exact same thing that you did in the other practice problems. So I'm basically saying if I start with this amount of Cl2, what amount of FeCl3 am I able to produce? So you're going to solve this just using your regular stoichiometry. Then here you're given the experimental yield. So the theoretical yield is what you'll get for your answer to A, and then you can use that to find your percent yield in B. So go ahead and pause the video and take a few minutes to work this problem. So first thing I want to do here is to balance my chemical equation. I've got 3 chlorines and 2 chlorines, and my least common denominator between those two is going to be 6. So I'm going to aim for 6 chlorines on each side. So if I put a 2 there and a 3 there, that gives me 6 Cl atoms on each side. And I have 2 FeCl molecules, or just Fe atoms here. And I'm going to need to put a 2 in front of this to balance out the iron. So we're starting with 3 liters of Cl2. We're going to convert that into moles of Cl2, then into moles of FeCl3, and then into grams of FeCl3. So starting with my 3 liters of chlorine gas over 1, I need to change my liters of Cl2 into moles of Cl2. Next comes my mole ratio to change moles of Cl2 into moles of FeCl3. And then because I want my final answer to be in grams, we're going to get rid of our moles of FeCl3 and convert using molar mass. So this first conversion factor is the liters per mole. So for any gas, 1 mole is 22.4 liters. Next, we have our mole ratio, which is going to be 2 to 3. And then I need the molar mass of FeCl3. So I'm going to take the mass of chlorine and triple it, and then add that to the mass of iron. So when I do that, I get 162.204 grams per mole. So solving here, I get 14.48 grams of FeCl3. So this is the theoretical yield. It's the amount of FeCl3 that I can get if I start with 3 liters of chlorine gas and excess iron and everything goes perfectly. But in lab, things do not go perfectly. So what I actually get when I do this reaction is 13.2. So to find my percent yield, I'm going to take what I actually got and divide that by what I could have gotten, and then multiply by 100%. It's kind of like your score on a quiz. It is the points you got divided by the points you could have gotten times 100%, and that gives you your quiz score. Well, if we take what we got from the experiment and divide it by what we could have gotten, multiply that by 100, that gives me a percent yield. So I get 91.16% here. So the last thing that you're going to need to complete is an exit ticket. So you can access this exit ticket through Brightspace or by typing this link into your browser.